problem 2. Just find the equation of the given line, write your answer in slope-intercept form. So again, same thing again, we want an equation in the form y equal mx plus b. So first step, right, step 1, we need to go ahead, we don't have slope, we need to go ahead and find slope. So let's go find m. So looking at m, right, m is your rise over your run, right? You're changing y over changing x. y2 minus y1 over x2 minus x1. And if you want, let's go over here to our graph. So we're looking at 2 points. So here's our line. We got a point 0, 0. And we've got a point, looks like 3, 6, right? So let's go ahead and plot that point. Right 3 up 6. So looking at it, of course, you can see your slope since you got your graph in front of you. Just reviewing the definition. What is our rise and run? So if you're traveling from point 1 to point 2, right? And let's draw it here differently. As we're traveling from 0, 0 up, right? So let's go ahead and highlight the rise factor. And then we'll highlight the run factor. So here's our rise, right? So we're rising. And how many units is that? We've gone from 0 to 6. We've gone up 6 units. And here's our run factor. So our run factor, right, is how far left and right. We've gone from 0 to 3 on the x-axis. So m, right, m should be 6 over 3, or 2. Now, you can go over here to your formula, right? You didn't have to use your definition, but you can plug in your numbers here. So again, y, let's label these, x1, y1, there's x2 and y2. But again, if we subtract the y coordinates, we're going to get that rise factor. 6 minus 0 is just 6, that vertical distance. And if we subtract the x coordinates, 3 minus 0, we get 3. So yeah, our slope, m equals 2. And now we got to find b. So again, right now, our equation. So we got y equal to mx of 2x plus b, right? M equal 2. All right, now let's go find b. So b is our missing part. So that's step 2. All right, go calculate that value. Find out where this line crosses through the y-axis. Well, we already have it, right? What is b? B is our y-intercept, right? So we already have that point. So y-intercept is equal to 0, 0. So that implies b equals 0. So this one's easy. We already can see the y-intercept point. So we don't have to plug in a point and solve a b. We already have that value. So here's our b value. So that implies our equation in slope-intercept form is y equal to 2x plus 0, which is just y equal to 2x, right? So again, given the graph, right, made that one quick and easy. We could see everything in front of us. That's finding that equation at a line. All right, let's do 2 more examples of equation of lines here on this page in problems 3 and 4, where it asks to find a horizontal line in problem 3 and then a vertical line in problem 4. So with these are actually the easiest we can run into. Quick and easy to find the equation of. Now, with that said, we've got a point. I'm going to draw. I like to see this one. Let's just draw in real quick our line, right, passing through this given point. It's vertical. So negative 6, 8. I'm going to go plot negative 6, 8. I'll put it in a different color, maybe blue. So left 6, up 8. So somewhere over here in quad 2, right, there's that point, negative 6, 8. Well, here's the graph of that vertical line. So we see a picture, right, of that vertical line. Now, one thing we know about this vertical line is that x always equals negative 6. For instance, the x-intercept be negative 6. So x is always constant. X is not changing, right? It's not going left and right. It's only going up and down. Only y values are changing. So that implies our horizontal, actually, somebody correct me. I've done this one totally opposite of what they asked. They didn't want vertical. I just did the directions there from problem 4. Let's correct this. It wanted the horizontal line passing through that point. So let's go ahead and draw in the horizontal, not the vertical. We'll get the vertical in our next example. All right, so let's draw in that line real quick. So here's the horizontal line, right? Line passing through negative 6, 8. Now what's not changing on a horizontal line are the y values. For example, the y-intercept point, right, would be 0, 8. So y is always equal to 8. It's constant, doesn't change, right? The only thing's changing are x values, going left and right, but not up and down. So there's no rise factor, which means our slope is 0. This is a slope of 0 or no slope. But as far as the horizontal line equation, I'll put HL, is y equal to 8, right? Y equals 8 on that line. So y equal constant is a horizontal line equation. X equal constant is a vertical line equation. So let's show now the vertical line example. So if you look at problem number 4, it's the same exact directions as far as the point is given. And again, I'll just redraw it down here in problem 4. And let's go ahead and plot in negative 6, 8. So left 6, up 8. So here's that point, negative 6, 8. And again, if I draw in the vertical line, right, here's a graph of the vertical. Like I said, the only thing that doesn't change on vertical is x values. So we got negative 6, 0, for example, for our x-intercept. So yeah, x is always equal to negative 6. X is constant, so we have no run factor, right? It's not going left and right, but we do have rise. With that said, I'll make a little note. We do know that m is undefined here. Right? If you have no run factor, you're dividing by 0, right, in your slope definition. So you can't divide by 0, undefined slope. Back up here, we'll make note in our last example, horizontal line equations, slope 0. So a little review there. But that implies our vertical line equation, right, which what we're looking for this line passing through negative 6, 8 is the equation of line x equal negative 6. There's the vertical line equation. So they're quick and easy to write. X equal constants vertical, y equal constants horizontal. Right? So again, that's reviewing lines, which we did at the beginning, right, of Module 6. So as we continue on here in a little bit, we'll look at some word problems, some basic applications using linear functions. We'll stop there and take a quick break.